Good afternoon. Let's take a look at homogeneous differential equations. So we've already taken a look at previous differential equations, separating the variables, but in this video we're going to focus specifically on homogeneous differential equations and what to do in case we identify one of these differential equations. So let's take a look here what is given. Of course, they say we should use the substitution y is equal to vx, but besides being given this, there are ways to identify that we have an homogeneous first order differential equation. So let's take a look here. We have dy dx is equal to x plus 2y over x. Of course, the first thing that I notice is I can actually separate this as x over x plus 2y over x. So now in the end I just have 1 plus 2, and if I were to write it out, y over x. So this is now dy dx. My first derivative of my function y is equal to 1 plus 2 y over x. Now the moment I see a y over x, normally this is a very good indicator that we're going to work with homogeneous differential equations. Now once I have simplified my equation like this, now let's go and take a look here at y is equal to v times x. So if we differentiate this, so in other words dy over dx, then we're going to have, so if I were to differentiate this, I should treat the v as a separate variable. So the moment I want to differentiate this in terms of x, I'm going to say that this is a product. So I'm going to say it is the first v times the derivative of the second, which is 1, because the derivative of x is 1, plus the second x times the derivative of the first, in this case dv dx. So I treated v as a variable. Now I have dy dx is equal to v plus x dv dx. Now what we have here is we have a dy dx, so I can replace this dy dx with what I have gotten here on the right hand side. So let's go and rewrite this now. So instead of dy dx, I'm going to say v plus x times dv dx is equal to 1 plus 2. Now they told us to replace y with v over x. So instead of y, I'm going to say, not v over x, v times x. So v times x over x. So I have replaced y with vx. And x over x, of course, is going to give me 1. So therefore, I actually have v plus x dv dx is equal to 1 plus 2v. Now once I have this, I can now go and try to get all my v's and my x's on either the left or the right hand side. I am going to treat this by separating the variables. So the first thing I want to do is I want to subtract a v on both sides to get rid of this v. So I'm going to have x dv dx is equal to 1 plus v, because I subtracted 1v on both sides. Now let's go and separate our dx and our v's. So what I'm going to do is, I can see here I divide by dx here. So if I'm going to multiply with a dx on both sides, so then I have x dv is equal to 1 plus v dx. And now of course I'm going to divide by 1 plus v on this side, and I'm going to divide by x on that side. So in the end I am left with 1 plus v on the left hand side dv is equal to 1 over x dx. And now I can take the integral of both sides, which will give me the natural log of 1 plus v is equal to the natural log of x plus c. And now I can just replace my v back. So remember, we had y is equal to v times x. If I want to make v the subject, then I can say v is equal to y over x. Now if I have this here, I can replace this down here at the bottom. So I'm going to say the natural log of 1 plus y over x is equal to the natural log of x plus c. They did not explicitly say that we have to write this in explicit form, therefore I can leave my answer like this, and this is the solution to the differential equation. Look here at the top, they say you may leave your answer in implicit form, therefore this will be our final answer. Let's take a look at another example. So here we have another homogeneous differential equation. Now, the first thing I notice here is that on the left hand side I have an x in front of dy dx. So what I want to do now is I first want to simplify this equation again. So I'm going to divide by x on both sides. So dy dx is equal to 3x minus 4y over x. And this can be simplified as dy dx is equal to 3 minus 4, and now again I have y over x. Previously we saw that the moment I have y over x, it is a very good indicator that I have here an homogeneous differential equation, and I can substitute y equal to v times x. So the same that I did previously, I'm going to say y is equal to vx. So dy dx, if I differentiate both sides in terms of x, v is a variable. So then again, I have v plus x dv dx. So I'm going to replace dy dx with this here. So we can replace dy dx with v plus x dv dx is equal to 3 minus 4, and instead of y, I'm going to have vx. So again, I have v times x over x, and x divided by x is 1, so I have 3 minus 4v. So if I want to put all my v's on the right hand side, so I'm going to subtract a v on both sides, so therefore 3 minus 5v, that's a v, sorry. Okay. 3 minus 5v, because it was minus 4v, minus another v is minus 5v. Now let's go and separate the variables. So I'm going to have 1 over 3 minus 5v dv on the left hand side, and 1 over x dx on the right hand side. If I integrate this, remember previously when we integrated, we know that 1 over something is going to be the natural log of this. But, of course, I have to find the derivative of the inside, which is negative 5. The reciprocal of that is 1 over negative 5. So 1 over negative 5 natural log of 3 minus 5v is equal to the natural log of x plus c. And then we can just replace v again with y over x, because we had y is equal to vx. If we make v the subject, then v is equal to y over x. So my final answer is going to be negative 1 over 5 natural log 3 minus 5y over x is equal to natural log of x plus c. And again, we can leave our answer in implicit form. I do not have to make y the subject.